Now that the robot is inside a Gazebo environment, you can apply an extended Kalman filter and localize it. The robot pose EKF package applies sensor fusion to the robot's sensor measurement to estimate its pose. Going through the robot pose EKF package, we see solid documentation with the launch file, different parameters, and the list of subscriber and publisher topics. Access this link in the instructor notes and go through the package documentation. As always, feel free to pause this video at any time to catch up with the lesson. After carefully reviewing the RoboPose EKF package, we can conclude that the RoboPose EKF node is subscribing to 3 different sensor topics and publishing a filtered pose. The EKF node is subscribing to the encoder's data through the ODOM topic. The EKF node is also subscribing to IMU data through the IMU data topic. Lastly, the node is subscribing to 3D odometry data through the VO topic. Now EKF is fusing all these 3 sensor values and publishing the filtered results to the Robot Pose EKF ODOM combined topic. To interface the Robot Pose EKF package with the TurtleBot Gazebo package and estimate the robot's pose, you'll need to rename some topics to match them with their others. At first glance, we see that depth imaging is unique to the TurtleBot Gazebo package, so the EKF node will not be able to subscribe to it. So let's cross it out in our diagram, as we won't be using it. The same applies to the 3D odometry topic, which is unique to the Robot Pose EKF package. We need to modify the EKF launch file in order to turn off the 3D odometry. Now we can see that the encoders perfectly match since they are not unique to any package and hold the same topic name. The same applies to the IMU data, but be careful here since the topic names are not identical. We should rename the IMU topic either in the TurtleBot package or in the EKF package. After performing the corresponding changes, you can see how the TurtleBot nodes are publishing sensor data directly to the EKF node. The EKF node will subscribe to the sensor data, remove the uncertainties, and ultimately estimate the robot's 3D pose. To rename a topic, go to the launch file of the package and then write this statement. Here, this statement is remapping the ODOM topic to a PR2-based odometry ODOM topic. We'll need to delete this statement since the ODOM topic of both packages are identical. Now, clone the EKF package inside the SRC folder of your Catkin workspace and edit the launch file with the following changes. First, delete the remap statement since we want the encoders to publish on the ODOM topic. Then, turn off the 3D odometry pose since it's unique to this package. Inside the same launch file, remap the IMU topic to match with the TurtleBot one. After you complete these steps, build your package and launch the node.